Good day, everyone. For today's discussion, we're going to talk about geologic structures. And this is prepared by Hoda Abubakar, Michelle Elaine, and Geraldine Amamangpang. So, our learning objectives for today's discussion are the following. Discuss deformation in its various forms. Discuss geologic structures. Discuss stress and strain. Discuss the type of stress. Discuss how rocks react to stress. And lastly, discuss the types of folds and faults. Now, let's take a look at these pictures. What do you think is going on with the rocks in these pictures? Is it bending, tilting, or breaking? If your answers are similar to mine, then you are correct. These images are examples of what we call deformation. Deformation is the process by which the Earth's crust bends, tilts, and breaks in response to stress. All changes in the original shape, size, and volume of a rocky body is a result of deformation. And here are some examples of forms as a result of deformation. We have anticline, syncline, monocline, dome and basin, faults, and many more. Now, do you have an idea about how deformation relates to our topic today? If so, let us begin by answering the question, what are geologic structures? Geologic structures, defined as the arrangements of rocks in the Earth's crust, which are moved via tectonic processes. Also, it is defined as any features in rocks formed by deformation such as folds, joints, and faults as a result of stresses. So in simple words, deformation causes geologic structures such as folds, joints, and faults as a result of stresses. So what is stress? Why does it cause deformation? Stress is a force acting on a rock per unit area. It is this force that causes rocks to deform. Moreover, in response to stress, rocks will undergo some form of bending or breaking or both. The bending or breaking of rock is called strain. Strain is defined as the deformation or displacement of material that results from an applied stress. There are three basic types of stress that deform rocks. First one is compressional stress. Compressional stress is a type of stress that occurs when rocks are squeezed or pushed together. This type of stress is typically associated with tectonic processes such as plate convergence, where two plates are colliding and pushing against each other. Collision of two continental plates leading to the formation of mountain ranges such as the Himalayas. Next is tensional stress. It is a type of stress that occurs when rocks are pulled apart or stretched. This type of stress is typically associated with tectonic processes such as divergent plate boundaries, where two plates are moving away from each other. Divergence of two tectonic plates leading to the formation of rift valley such as East African Rift Valley. Lastly is shear stress. It is a type of stress that occurs when rocks are subjected to forces that cause them to slide past each other in opposite directions. This type of stress is typically associated with tectonic processes such as transform plate boundaries, where two plates are sliding past each other, such as the San Andreas Fault. So now, how rocks are going to react to stress? There are three ways rocks can react. First is elastic deformation. When the stress is removed, material returns to its original shape. Elastic deformation is caused under conditions of low stress when the material is compressed, bent, or stretched, just like a rubber band that reverts to its original shape after being stretched. Next is ductile deformation. Ductile deformation occurs when enough stress is applied to a material that the changes in its shapes are permanent. Example of this is a metal bar that is being bent. If you bend the metal bar too far, it can be permanently bent out of shape and the material is no longer able to revert to its original shape. Lastly, brittle deformation typically occurs in rocks that are near the Earth's surface, where they are subjected to relatively low temperatures and pressures. It can also occur in rocks that are subjected to sudden and rapid changes in stress, such as those associated with earthquakes or other seismic events. The rocks will break rather than bend under this condition to produce fractures. When a rock is subjected to a high enough stress, it can break along a plane of weakness, forming a fracture or fault. Here are some factors that influence the formation mechanism. First, temperature. Temperature has a significant impact on the formation mechanisms. At a low temperatures, the formation is typically brittle, while at high temperatures, the formation is typically ductile. Next is pressure. Pressure also plays a role in the formation mechanisms. High pressure tends to favor ductile deformation, while low pressure favors brittle deformation. Lastly is time. The duration of stress also plays a role in the formation mechanisms. Slow, sustained stress tends to favor ductile deformation, while rapid short-term stress tends to favor brittle deformation. Now let's move on to fold. Fold is a geologic formation formed by the folding or bending of rock layers or beds. Folding is due to compressive stresses. Folds are some of the most common geological phenomena you see in the world. It is a geologic feature that resembles a wave that develops when a compressional force causes rocks to deform by bending rather than breaking. Folds generally occur at great depth in the Earth's crust, where the rock layers are exposed to high temperatures and pressures. Here are the types of folds. First, syncline is a concave fold in which the younger layers are closer to the center. Synclines are typically a downward fold pointing upwards. The top can also be eroded so you can only see the edges of the formation. Next is anticline. If you have noticed, anticline is like a syncline but in reverse. An anticline is a fold that convex up and has its oldest bed at its core. Anticlines are often flanked by synclines, although in real life, additional faulting in erosion can mask the relationship between the two. Anticlines form many excellent hydrocarbon traps and so are very interesting for oil prospectors. Next is monocline, a geological structure in which all the layers are bent in one direction. There are several ways through which a monocline can be formed, but the most common one is the differential compaction over an underlying structure. Next is chevron, the chevron fold named after the major oil companies. It is a type of fold with repeated V-shaped beds forming in response to compressive stress and requiring specific conditions. Next is recumbent fold. Recumbent folds are overturned folds. An overturned fold or overfold has the axial plane inclined to such an extent that the strata on one limb are overturned. A recumbent fold has an essentially horizontal axial plane. Next is isoclinal fold or isoclines. It have an interlimb angle of between 10 degrees and 0 with essentially parallel limbs. Next is plunging fold. Plunging fold is a fold whose axis plane is not horizontal or not parallel to sea level. The direction of plunge is the direction in which the axis is inclined nose. Indicate the direction of plunge. In anticline, plunge is directed towards nose, and in syncline, it is directed away from nose. Next is dome. Dome is a feature in structural geology consisting of symmetrical anticlines that intersect each other at their respective apexes. Dome can be formed by either horizontal stresses in a process known as refolding, meteoric impact, or through diapirism. It is the vertical displacement caused by an initially deeper and lighter body as it moves towards the surface. Next is basin. Basin is the opposite of dome. Large-scale structural formation of rock strata formed by tectonic warping of previously flat-lying strata. Structural basins are geologically depressions. Next is stigmatic folds. Stigmatic folds are chaotic, random, and disconnected, typical of sedimentary slump folding, migmatites, and decollement detachment zones. Lastly is slump folds. Slump folds are formed when a mass of sediment becomes unstable and slides down a slope. This can happen due to a variety of factors such as heavy rain, earthquake shaking, or overstepping of the slope. As the sediment slides down the slope, it can become folded and deformed. Now we are done identifying the types of fold. Now let's move on to fault. What is fault? Fault is a fracture or crack where two rock blocks slide past one to another. If this movement may occur rapidly, it can be causes earthquake or slowly in the form of creep. Types of faults include strike-slip faults, normal faults, reverse faults, thrust faults, and oblique slip faults. It can be small and large complex interconnection fault system and can replace one type of fault in one location with another type in another. Many faults are associated with folds. Faults are separated, bifurcated, convergence, or move away from distances that sometimes creating complex fracture system. These are the types of faults. The first fault is a normal fault. A normal fault appears to be that suspended wall moves downward relative to the footwall. The deep angle of sliding surface is between 45 and 90 degrees. Many normal faults in mountainous regions are caused by gravity along the edges of the mountains and may be associated with the elevation of the head wall of the slumps. So the second type is a reverse fault. Reverse fault is which the hanging wall moves upward relative to the foot wall. So the last deep slip fault is a strike slip fault. It is a generally vertical fault where two sides pass horizontally past each other. If the block opposite an observer facing the fault moves to the right, the shift style is called right lateral. If the block moves to the left, the movement is called left lateral. The San Andreas Fault in California is the most famous example of a right lateral impact slip fault. Additionally, there is another type of fault, the oblique slip fault. Oblique slip faults show important components of both horizontal, which is the impact slip, and vertical, the slip shift motion. The oblique slip error combines the impact slip motion with significant normal, reversed, or push slip.